Hello, everybody. Good morning again. Welcome to Digital Business. This is lecture number 5, Digital Business Infrastructure. And this is Dr. Mustafa Muhammad, your lecturer for today. So today I'm going to extend your knowledge far further than the previous 2 weeks, where we're going to talk about specific technology-related concepts and terminologies to address the so-called digital infrastructure. This week we will have lecture 5 and lecture 6, which will come next after this one. So in this one I'm going to start talking about the internet revolution and the key elements, the key terminologies of the so-called internet and World Wide Web, and then cloud computing. Two important topics that would really help you to get to understand what we mean by digital business, and especially the infrastructure side. So let's start with the first element, which is the internet revolution. If you remember the last 2 weeks, and especially last week, I've been talking about the historical revolution of the World Wide Web, and we discussed two concepts: the internet, which is a sort of interconnected networks, thousands of networks getting together. They link businesses, educational institutions, governments, agencies, and individuals. While the World Wide Web is a sort of the most popular service of the internet, it provides access for these billions of people, exponential benefits for all of them, and they do deliver more transactional based service, exchanging information, which would lead to exchanging value and financial value later on, and even conducting financial transactions immediately through the World Wide Web service. So this is what we discussed last week. We also mentioned the revolution of the internet, and we discussed where we are at the moment. So we are still in the commercialization phase, and you could see that Amazon founder stepped down or plan to step down soon, because his fortune is getting really big, and he doesn't really need to continue in the top than to consult the new CEO. So he will be an executive chairman for the company. And surprisingly, we wouldn't say surprisingly, interestingly enough, the revenues for Christmas, so Amazon's Christmas revenues reached around 100 billion American dollars, which is equal to maybe a country's whole overall economy. That's impressive. So this is where we are, and we need to understand the infrastructure of these things, of something like Amazon, any web-based service. We need to understand what's going on out there, and the infrastructure terminologies. So in the future, when we try to develop a website, a mobile app, or virtual reality app, in the future, if you wanted to extend your own technical knowledge, because this module and the whole program is not targeting computer science students. I would say computer science and the technical side is interesting, but your payment, your salaries wouldn't be as high as a managerial job or a business-based job. So if you have this business experience later on, and the knowledge that you get from this course and the whole program, it would help you to get to bridge between the technical people and the top executives and get a higher salary than just being a technical and computer science side. So let's start talking about what are the key components of internet infrastructure. Usually you have every page, every instance of a page is loading on computer web browser, is made by a sort of language called a really simple syndication, which is RSS, and you feel free to read further about it. It's just one of these languages for the static internet, which is a way to push information from a sender to a recipient. Later on we'll talk about different versions of the World Wide Web, where we will have other languages. So these languages are fed in real-time streaming into a reader, and this reader is called Internet Protocol. Now, consider this as a sort of phone call, which we can, call it then voice over Internet Protocol, that, conveys messages from the sender to the recipient. Its basic components includes data centers, big buildings, and we are going to discuss this soon, networks of personal computers, mega, computers, servers, storage devices, and server applications and software, or the operating system. The hardware may be localized in specific countries. For example, for Europe, we have a specific country that hosts the European access to the World Wide Web, though the infrastructure spans everywhere. So you have, signal towers, you have different telecommunication infrastructure that connects these networks and devices and storage servers and all of this. So this is not a surprise when you discover that most of the web service is provided by mobile telecoms and service providers or internet service providers. So the internet service providers the majority of them are mobile telecoms actually. So the first component, data center, which is a sort of, you have these massive buildings to process and store data. They are fully equipped with staff, team of operators who would have the experience on how to store data, keep privacy and the legal, ways of storing data. They are licensed people with equipments, enough power supply, and plan B or backup power supply. These data centers are regulated in terms of, even the temperature, the climate, on how to deal with data, fire, cover system, any unauthorized access like hacking, fraud. All of this, they are fully equipped against these things. So this is the first element of the World Wide Web. In England, you need to think maybe in your own time, try to list what are the biggest data centers in England. So maybe, have a go, Google it and find, list maybe 10 data centers around UK. The second component of the internet infrastructure is a network of processors and storage devices. And usually these network of processors are measured in megabytes and gigabytes. These are massive networks that allow data to be transferred between processors and storage devices, the personal devices, to the mega, devices hosted in the network of these processors. The ultimate goal is for information to reach the computer or devices at the end user side. So let's say this is like mainstream platforms that connects end users together through the network. The network is usually hosted by a modem or the internet service provider, and we will have these concepts explained later on. So you either connect yourself with a modem or your own, private provider, or your work internet service provider. It depends. So the third element of components of infrastructure or internet infrastructure, servers. So this includes high-end computers that reassemble desktop PCs, is measured in units of processing power, which is a sort of, we call it RAMs. You can have the same concept, you can see it in your own personal PC. So the storage capacity is by how many RAMs, and it must be connected to a power supply, as I mentioned, as well as a network and installed operating system within the server. So keep connecting different subnetworks and the mega networks with the personal computers and end user laptops and devices. A server can consist of a single computer, a pool of computers, or even clusters of pods in different locations. The fourth element, the fourth component of the digital infrastructure of this internet is called operating software or service application, which is hosted in the server that I just mentioned. Any server must have an operating system like Linux or Windows. It depends if you have Mac device or like Apple device or Microsoft device. A server must have a web server application such as Apache, Microsoft operating system as well, as I just mentioned, a database for data mining and sorting, data and classifying data, processing data, such as MySQL or Oracle or other programming and data mining language. You don't need to know all these expressions in details, but just get used to what are these things, what do we mean by these things. But you don't need to go deeply within each concept. The user can install any other subsidiary web applications hosted on this operating software. So after we discussed the four key elements of internet infrastructure, I'm going to talk to you about some simple terminologies that we need to discuss here, so it would help you in your studies further. Back switching or packet switching. Now, let's agree that whenever a device is conveying a message, it needs a sort of language. But this language need to be digitalized, a sort of decimal barcode. This barcode is a mix of zeros and ones together. But once we have this, you might have, for example, a long message decoded in maybe a set of 100 to 200 digits, 0, 1, 1, 1, 0, 0, 0. All this need to be buckets in sort of sets or bags or grouped into short codes, and each code would reflect a word or a meaning. So you need packet switching, which is a device that packets digital messages and sends them along different communication paths. So if you want to send a message to another personal device, personal computer or a laptop, this packet switching device in your laptop helps sending this through different communication paths. The device in your machine, in your own device, reassembles packets at the destination again. So if somebody sends you a message, it interprets the codes into packets, and it identifies the user routes, where it came from, who's the sender, what timing. It can get to tell you the internet protocol of this sender, where he is located as well. So it works this way. Let's assume you want to say, I wanted to communicate with you. This is the message. Then the packet switching interprets this message into a series of codes, of barcodes, 1, 0, 1, 1, whatever. So this is the lengthy message. The packet switching then groups each word into specific set of codes. It gets broken into bits, and each bit reflects a meaning of a word, or alphabet or abbreviation, depends. But then the machine, this device, adds a sort of title to it or a header to it that tells The destination indicates the sort of destination, that where it is going to. The control information, how many digits, how many words, what type of message is this, how many packets included. So this header, for example, that you see here in my machine, 0011001 is the header, and it's usually shorter. And then this is how it works. So you have 3 routes for a message from you as host 1 going to host 2. These sets get sent through different nodes, and then the receiver, the recipient, can tell the key routes where this message came from. So this is how it works. Another concept that we will explore together, the internet protocol. It's established, this is the reader, this is the language that reads the codes, the barcodes that we just mentioned. So it establishes connections among sending and receiving web computers. So all these devices that are connected through the web get connected through internet protocol. It handles assembly of packets at points of transmission and reassemble at receiving ends. So if we go back to these routes, all these routes have different internet protocols. And this is how, for example, if you received an email here as a recipient, we can always discover the internet protocol through which this message has been sent. Did it come through a laptop in that place? So what are the key nodes that this message came through? Did it come this way from France, or maybe a hacker somewhere else in a different country who sent a message through a server in France to your device, or maybe in other countries? This is just an example. Okay? So, moving forward towards another concept, and as you can see here, this is the internet protocol, how it works from device A to device B. Overall, this is how a message gets transmitted. So you have a file, which is sort of application process, let's say Microsoft Office 365. You write messages in a Word file, which gets interpreted in terms of bytes, and then gets through this transmitter, gets decoded into barcodes from 0 to 1 digits, and then sent through this transmitter as a buffer message that gets sent to the recipient in the other side. There are different segments, different nodes. Then another transmitter in the recipient device get to decode this message, which makes it a receive buffer, and then interpret this from a code into a Word file, or sort of application process to be read in a clear way. This diagram here is talking to you about the architect, the overall architect of the internet. On the left side, you can see what we discussed overall. There is a network interface layer where the service provider is processing things. An example, a standard traditional example of this sort of interface layer is Ethernet. Internet layer, where we have this World Wide Web, this cloud over there with IB internet protocols, and then within each device, end user, or a network server, there is a host-to-host transport layer where there is a transmission that buckets these languages and decodes them. And then the application layer, which could be HTTP language, any web interface that you have, any type of web browser that you have in your device. I urge all of you guys, maybe you can explore these things further in your own way. You don't need to have deep technical knowledge about it, just to get to know what are these abbreviations, and do you really use them in your life, in your work, in your studies. Okay, another concept, which is client-server computing. It's a powerful personal computer connected in the network, which is your device. It stores file, software applications, and access to printers. So this is the end user computer, but this is another way to call it client or server computing. Internet service provider versus local area network, which I mentioned at the beginning, is that you may use your modem or dial a local number to connect an internet service provider. So this could be a private one that you pay through your landline. So you call a specific number and you get connected to this hot space of internet service provider. Or you might have your own router or your own broadband, and somehow you initiate a call to the internet service provider. You may be part of your local area network though, but you must likely still connect it to the internet using an internet service provider. So let's say you have a local community who hosts their own local area network or lane. Once you connect to them, it's okay, you still become part of them and you can share files and folders, but they also need to have their own internet service provider. So we either have direct connection to the internet service provider or indirect one through the local area network that itself might have subscription or pay for the internet service provider. The internet service provider may then connect to a larger network and become part of a bigger and bigger network. So for example, different mobile telecoms get together in a larger network, which is hosted in the European network. Point of presence is another concept that you might go through when you study internet infrastructure. It's a sort of local place for local users to access company's network, or often local phone number or dedicated hotline that you can go through. You can see many of these hotspots on streets, so you can go and access the internet, pay as you go. So what we've been through since the beginning, we've spoken about a sort of evolution of internet infrastructure. We've spoken about what are the key terminologies that we use since the beginning until the commercialization stage. We've spoken about the key components of internet infrastructure, 4 key components, and then we've spoken about key concepts, from the way we have a reader, internet protocol, which is a voice call or a dial-up call. We have transmitter. The transmitter packets or group is a language which includes barcodes, a mix of zeros and ones, and other terminologies. So overall, what we've spoken about is called Web 1, which is a static web communication, a sender and recipient. Though it doesn't have this dual communication as you go. Since 2006, we started witnessing another wave, which is a social media wave, or we call it Web 2, or the second version of the web, where exponential number of users can exchange values, information. They can co-create videos. For example, Banopto here is one of these examples that I can get a real video and add something in the video. Adobe, different softwares that could help us to recreate and co-create things and then push them on the web. So it's mainly read and write generated languages, which started from 2006. Though we even started to witness Web3. Now, what is Web3? It's more smarter. It helps respond, search, teach, memorize things. So, for example, you speak in front of your WhatsApp, and suddenly it connects to Facebook, and you're emailing, and you get different commercials related to what you say. So, this intelligent version of the web called 3.0 or third version that helps you to do analytics. It gets connected to your mobile phone actually. It tracks your location, connects with the GPS service. All lots of advanced and smart machine learning activities. So this web language is more advanced. If we go back here, now this is a dual way. You can read and write, but here you can do even much more. A whole living assistant, personal assistant that lives with you. So the first version we have HTML read language, then XML or RSS languages that we started to have, which read and write, and then more XHTML and other more advanced personalization language. The second version helps you to collaborate and co-create things, but the third one helps you to personalize what you really need from the web, and whoever can communicate with you get to know who you really are and what you really need. So we've been through the first part of lecture 5, the so-called digital infrastructure or digital business infrastructure. We've been through different concepts, terminologies, key components of internet infrastructure. We've spoken about the architect of internet platforms. The second part is cloud computing. Last week I gave you a sort of hint for the so-called cloud computing, and now I'm going to continue talking to you about different layers and the models, challenges and the benefits of cloud computing, so you get to know what it is. Last week we mentioned this concept called computing as utility, and we've spoken that we have the right to access to computing, as we have the right to access utility, air, fresh air, clean water, all of these things. So cloud computing is a sort of a model to enable anonymous and even identified on-demand network, a ball and shared connection and shared collection of computer resources, including all internet-based services and components, networks, servers, storage areas, applications, and services that can be rapidly provided and with minimal and maybe no supervision. You don't really need supervision or continuous interaction to manage these things. So it's self-managed. We've spoken about different characteristics of cloud computing last week. It is on-demand service, so it could be measured by how many mega and gigabytes gets uploaded and downloaded. It helps you to get resources, computing resources from India, China, Europe, all together at the same time. Broad network access using different devices, mobile phones, tablets, personal computers and desktops. Rapid elasticity, it gets smooth with you in high peak of demand, and whenever you have no demand, you don't need to pay a huge amount of money. You simply don't pay unless you use it. It could be measured, and we pay as we go. So all of these things have been mentioned last week. Now I'm going to take you a step further, deeper into this cloud computing and the infrastructure of cloud computing. As you can see here from Zing 2010, which he's the role model author of cloud computing actually. His paper inspired many people to go ahead with this area of knowledge. So he assumes that any cloud-based service includes 3 layers. Infrastructure layer, as you can see here on the left side. So infrastructure as service. So how you can really share the infrastructure of your communication networks and hardware with other companies, with other countries, with other small businesses. So you have here a mix between data centers where they have hardware, memory disks, and mega computers, and then they have a sort of infrastructure level, which data mining and computation storage that classifies data and put data into folders and codifies them. An example of this is Amazon. Amazon infrastructure. You can use Amazon to host your own business, and then you can provide Amazon EC2 and GoGrid and different infrastructure as service. So by doing this, you actually share your infrastructure. It's called IaaS, or infrastructure as service. The upper layer, which is closer to the end user, is called the platform as service, where you share the software framework, the language, which is Java, Python, the storage area itself. So somebody can go use detailed storage area with specific languages and with specific programming things. But then this company who can, or individual or small businesses who share your platform would host their own interface, and they will install their own software. So their end users can use different languages, can use different colors, different personalization, which means there is an upper layer called software as service, which is SaaS, where business applications, web browsers, and multimedia, YouTube, whatever, Google Apps, Google Drive, Salesforce, which is customer relationship management system, Facebook, all of these are end user business applications and multimedia. So if you share, for example, if you go and pay for Google Drive or Dropbox, this means you are sharing the interface and the multimedia web service with Dropbox company, and this is why you might need to pay them. So they offer you free service, and then you need to upgrade later on. So 3 layers. From the bottom, infrastructure as service, platform, middle level, software as service is top level. And you have examples of these in the right corner. Feel free to go and Google them and explore them. Now, there are different deployment models. Deployment models, which means the business and informatics application of these layers. So, for example, private cloud. Let's say IBM or BMW or any automotive, any corporation, they might have their own cloud server where they host their own data. This private cloud is not accessible by non-members, people who have no authorized access to the cloud space. Example of this is Salesforce, Oracle, and other examples. Community cloud. Community cloud is mainly it's not private because you don't really need to pay for this, but it helps delivering a charity purposes, for example. So charities would have this community cloud that enables fostering schemes where you have hosting parents and the government that goes there to monitor. Social workers, all of them would have access to this community cloud. A specific level of public access would be there for the public, for the common public. So if somebody wants to foster, they can get to know simple level of information and then get contact details, but it's not completely public, otherwise it would be a hazard, because there are data about kids and personal homes and personal information about fostering parents and other things. So this community cloud is sort of something between private and public. Though the public cloud is completely public, so the council, Manchester City Council, the Newcastle City Council, London City Council, they would have their own public cloud where they host every detailed about street reconstruction, building new houses, providing specific, for example, office mailing services, Royal Mail Service, other public services. So you can get to know what's going on, and they would deliver transparent and controllable service. A hybrid cloud would be something like a mix of all of this. So I would say, for example, Mambo is one of these community clouds where microfinance institutions can get to know, can get to communicate each other. So Mambo, I was personally involved in developing this system. So it started in France, and then Algeria, Tunisia, and then to different Middle Eastern countries. So it has a specific level of access for normal people to get to know how they apply for microloans. But then all microfinance institutions get connected together, and they rate, they have a sort of rating score for each client. So in the second section here, we've been talking about what is cloud computing as utility, the key features of cloud computing as we go service, and then we've spoken about the deployment models. Now I'm going to talk to you about the benefits. So there are business benefits, no upfront investment, so you don't need to pay as you pay for Oracle or SAP, where you pay millions of American dollars or sterling pounds, and then if you don't use them, you're stuck, you have to keep paying, or you pay penalty for canceling the contract. Lowering operating cost, simply you don't need many people to maintain the fixed system as we do with mega enterprise systems. Highly scalable, it's quite flexible. You reduce business risk by downloading your data at once. You can have a backup, and at any time anybody hacks you can change the password, change your access authorization. You can easily use this backup and host it in another cloud provider than Rackspace or whatever the cloud provider is. So these are the business benefits. Technological benefits, great computing. You can have easy customized languages and interface. The virtualization itself is centralized, so you can control different branches who have different scattered information and data in different locations. You can always classify which language would they use to upload and download data and process data. You can choose the location of saving data, different things. You can have analytics, less maintenance cost, so you don't need the IT people to keep dealing with the IT providers and these companies who provide the software. It's completely synchronized. It helps you to develop different reporting techniques and easy interface. The social benefits, it's clean, clean energy, green energy. You don't have to install lots of PCs and mainframe computers and and big data centers in your place, and you have carbon emissions. This is not clean. So the cloud is doing this for you. You have data centers hosted in India or somewhere else, far away from populated areas, and yeah, it's clean, cheaper computing as well, and reach out to excluded zones, and somewhere where people don't have appropriate infrastructure. Okay guys, so we've been through two sections here about infrastructure, internet and World Wide Web infrastructure, and cloud computing infrastructure. These are the key references, and luckily I do have a paper about cloud computing. I wish you enjoy reading it, and definitely the core book chapter 2 is quite useful to cover these readings. You have a lovely day, and see you again in lecture 6.